Harvard astrophysicist Avi Loeb has just released a controversial analysis of interstellar visitor 3I, Atlas. He argues this object may not be a normal comet at all. The evidence is real. The data is quantifiable. The implications are staggering. Loeb points to mass loss so extreme it would erase a large building every second, 2 million kilograms of ice and dust blown off in moments. He notes motion that seems to gain speed in a way normal comets struggle to explain. 60 kilometers per second fast enough to cross a country in under a minute. The numbers don't lie. The behavior defies expectations. What Loeb's calculations show is a pattern that shouldn't exist for a simple block of ice. Then comes the radio twist. MeerKAT detected 2 narrow features, signals tied to broken water molecules. On their own, they look natural, but Loeb treats them as part of a bigger, stranger picture. A giant dry ice-rich object with an overpowered tail, odd motion, and radioactivity in a band. Long watched by SETI teams. The math is solid. The puzzle is real. This object entered our solar system at impossible speeds. Not just fast, hyperbolic, interstellar. The kind of velocity that screams origin from another star system entirely. Loeb's analysis starts with the basics. The raw observational data. Atlas telescope in Chile spotted it first. July 2025. Initially classified as an asteroid, no visible activity, just a dot moving too fast. But something was wrong from the beginning. The trajectory didn't match anything from our solar system. This wasn't a local object. This came from deep space. Think about that for a second. An object the size of a small city flying through our cosmic neighborhood. From somewhere else, from another star. And that's when things got interesting. Because this object started changing, not gradually, dramatically. As it approached the sun, telescopes worldwide turned to watch. What they saw challenged everything. Loeb's calculations focus on what happened next. The object began shedding mass at rates that defy simple explanation. Not hundreds of kilograms per second, not thousands, millions, 2 million kilograms, vaporizing every single second near its closest solar approach. That's not normal comet behavior. That's extreme. To put this in perspective, imagine a 10-story building. Now imagine it turning to gas every second. That's the scale of mass loss Loeb documented. The Harvard analysis goes deeper because mass loss creates thrust. Always has. Basic physics. But the thrust pattern here doesn't match standard models. Loeb shows acceleration components that shouldn't exist. Sideways pushes, speed changes, trajectory alterations, all measurable, all documented, all wrong for a simple ice ball. Here's where it gets controversial. Standard comet models say gas jets push randomly, ice heats, cracks form, gas escapes, object tumbles. But Loeb's math shows something different. Organized thrust, directional changes, almost like steering. The calculations are based on 173 days of observations, multiple telescopes, independent teams, consistent results. The object gains speed in ways gravity alone can't explain. And then came the radio detection. The 24th of October 2025, South Africa's MeerKAT array. 2 distinct radio emissions, 1.665 and 1.667 gigahertz, hydroxyl lines, OH molecules, broken water in the coma. Natural? Maybe. Significant? Absolutely. Because these exact frequencies have been monitored by SETI for decades. The cosmic waterhole where intelligence signals might hide. Loeb doesn't claim it's artificial. He's too careful for that. But he notes the coincidence, the timing, the intensity. Radio emissions strong enough to detect from Earth, from an object already behaving strangely. The Harvard analysis layers evidence like a prosecutor building a case. First, the impossible trajectory from interstellar space. Second, the extreme mass loss defying normal patterns. Third, the non-gravitational acceleration, suggesting controlled thrust. Fourth, the radio emissions at watched frequencies. Each piece alone has explanations. Together they form a pattern. But that's just the beginning, because spectroscopy revealed something nobody expected. This isn't a water ice comet like most in our solar system. This is carbon dioxide ice, dry ice, 8 times more CO2 than water. Loeb's analysis shows why this matters. CO2 sublimates differently than water ice, creates different thrust patterns, different jet structures, could explain some of the strange motion, maybe, but not all of it. The numbers still don't add up. JWST observations from August 2025 confirmed the bizarre composition: carbon monoxide, carbonyl sulfide, organic compounds, a chemical signature unlike any comet we've catalogued. Foreign, alien, different, not necessarily artificial, but definitely not from here. Loeb frames this carefully in his analysis. These chemicals exist in nature, we know that. But this specific combination, this ratio, this behavior, that's what makes his calculations so unsettling. Because when you run the models, something's missing. The observed acceleration exceeds what the measured gas can produce by a factor that's small but real, measurable, significant. Think about what that implies. Either we're measuring wrong, which multiple teams dispute, or there's thrust we can't see, hidden acceleration, unknown forces. That's not a comfortable conclusion for mainstream astronomy, but Loeb's math is thorough, peer-reviewed methodology, standard calculations, just applied to non-standard observations. The anti-tail formation provides another puzzle piece. After perihelion closest solar approach, something strange appeared. Not just a normal comet tail, an anti-tail, dust and gas pointing toward the Sunday against solar wind. Geometry can explain this, viewing angles, orbital mechanics, but the intensity, the structure, the duration, Loeb's models show these exceed normal parameters. Images from November 8 to 12 reveal the full picture. Multiple jets, organised patterns, structured outflow, not random venting, directional release, like thrust vectors on a spacecraft. That's not Loeb's claim, that's what the geometry suggests. The controversy deepens when you examine the timeline. This object was discovered in July, studied for months. Every observation added questions rather than answers. Initial classification, asteroid, no visible coma. Revised classification, comet, sudden activity. Current classification, active comet with anomalous characteristics. But classifications are human constructs, labels we apply. The object doesn't care what we call it. It just keeps behaving in ways that challenge our models. Loeb's latest calculations focus on energy balance, solar radiation in, thermal emission out, mass loss measured. The books should balance. Energy conserved, physics satisfied, but there's excess acceleration, small but persistent. Where does that energy come from? Natural explanations exist. Loeb acknowledges every one. Volatile pockets, subsurface pressure, exotic ice phases, each could contribute, none fully explain the observations. That's the crux of his argument, the gap in our understanding. But that's where the official story starts to fall apart, because mainstream astronomers are pushing back hard. They point to fresh observations that complicate Loeb's narrative. The MeerKAT radio detection, they say it's perfectly natural. Hydroxyl emissions from photodissociated water, standard comet signature, no patterns, no modulation, no information content, just molecules breaking apart in sunlight. British teams analysing the same data reach different conclusions. The radio lines are smooth, thermal, natural, exactly what you'd expect from a stressed comet. No evidence of technology, no signs of artificiality, just unusual chemistry in an unusual object. And here's what makes this so controversial. Both interpretations use the same data, same observations, different assumptions, different models, different conclusions. Science at the edge of knowledge, where certainty dissolves. South African astronomers who made the detection lean toward natural explanations. They've seen similar signals from known comets, lower intensity, sure, different chemistry, yes, but the same basic physics, same molecular transitions, nothing that screams alien technology, yet Loeb's math remains solid. The acceleration anomaly persists. The mass loss stays extreme. The trajectory still shows that inexplicable push. Small, subtle, but stubbornly present in the data. European Space Agency observations add another layer. Mars Express caught the object during its October Mars flyby. The images show a fully developed coma, classic comet appearance, but the brightness variations don't match predictions. Fluctuations too rapid, changes too dramatic, like something's happening beneath the surface. ESA scientists propose natural explanations, rotating nucleus, volatile pockets, fragmentation events, all possible, all precedented, all incomplete. Because when you model these scenarios, gaps remain. The math doesn't quite close. The energy doesn't balance. Something's still missing from our understanding. That's what divides the scientific community. Not whether the object is strange, everyone agrees there, but whether strangeness requires exotic explanations or just represents gaps in comet science. NASA's position remains cautiously neutral. Their Horizons database tracks the object precisely. Orbital elements, positional data, brightness measurements, raw information without interpretation. Let the data speak, let scientists debate. But even NASA's careful measurements show the anomaly. Small non-gravitational forces, persistent acceleration components, present in every orbital solution, acknowledged in every model, just not explained, not fully, not yet. The JWST team preparing December observations knows the stakes. Their spectroscopic data could settle debates or deepen mysteries. High-resolution spectra, isotope ratios, molecular abundances, fingerprints that might reveal origin, natural or otherwise. The questions they're targeting are specific. Does the CO2 to water ratio stay constant? Do organic compounds show biological signatures? Are there absorption lines we've never seen? Each answer will shift the debate. Recent images from ground-based telescopes add urgency. The tail structure keeps evolving, growing, changing. November 12, observations show unprecedented detail. Ion tail stretching millions of kilometers, dust tail curving gracefully. Both normal for comets, both extreme in scale, like someone turned the intensity to 11. Virtual telescope project data reveals fine structure, jet patterns, shell formations, concentric halos, beautiful, natural, probably. But the symmetry bothers some analysts. Too organized, too regular, too perfect. Nature usually messier, more chaotic, less structured. Unless there's underlying order we don't understand. The December 19 closest approach looms large. Earth-based telescopes will have their best view. Radar might pierce the coma. Reveal nuclear structure. Answer questions or multiply them. Because here's the uncomfortable truth. If this object maintains its anomalous acceleration, if the radio emissions show any structure, if the chemistry remains this exotic, then Loeb's questions become everyone's questions, not conclusions. Questions, the kind that reshape scientific understanding. Two competing narratives now frame the debate. First, a rare but natural interstellar comet, unusual chemistry from formation in another system, extreme activity from volatile rich composition, strange motion from complex outgassing patterns, all natural, all explicable eventually. Second, something that challenges our categories, not necessarily artificial, but not simply natural either, something that sits at the boundary of our understanding, where physics meets philosophy, where data meets interpretation. Loeb himself remains scientifically cautious. He frames this as investigation, not declaration, presents calculations, shows anomalies, asks questions, never claims proof, never asserts certainty, just points to gaps where mysteries live, the scientific method at its most honest. His latest blog posts emphasize this repeatedly. Future observations will decide. Data will determine truth, not belief, not preference, not assumption, measurement, calculation, evidence. The December JWST observations carry special weight. Infrared eyes that see through the coma, spectroscopic precision that reveals atomic truth. If patterns exist, JWST will find them. If chemistry stays exotic, JWST will confirm. If acceleration anomalies persist, JWST will measure. Ground-based telescopes join the effort. Gemini, VLT, Magellan, Rubin, each with unique capabilities, different wavelengths, various techniques, building a complete picture, mapping the unknown. The questions they're asking cut deep. Is the nucleus intact or fragmenting? Do the jets follow solar heating or something else? Can we explain the motion with known physics? Every answer matters. Every measurement counts, because we're not just studying a comet, we're testing our understanding of what's possible, what nature creates, what physics allows, what might exist beyond Earth. The radio observations continue too. MeerKAT schedules follow-up observations, looking for changes, patterns, evolution. If the hydroxyl lines vary systematically, if new frequencies appear, if any modulation emerges, the implications would be staggering. But absence of evidence isn't evidence of absence. Natural explanations remain most likely, just not certain, not proven, not complete. That's what makes this moment so extraordinary. We're watching science happen in real time, hypotheses competing, data accumulating, understanding evolving, the kind of investigation that defines breakthrough moments. Whether this object proves natural or suggests something more, the process itself advances human knowledge, forces us to question assumptions, refine models, expand possibilities. That's Loeb's real contribution here. Not claiming aliens, not asserting artificiality, but asking hard questions, following data wherever it leads, maintaining scientific rigor while embracing mystery, the balance that drives discovery. His calculations stand as challenge to the community. Explain these numbers, account for these anomalies, use known physics, standard models, natural processes, if you can, if they work, if they're sufficient. But if they're not, if gaps remain after every natural explanation, if the data keeps defying our models, then we have to consider alternatives, not jump to them, consider them. That's scientific honesty. Intellectual courage, admitting when our knowledge hits limits, the stakes extend beyond one object. 3. I, Atlas, is our third. Confirmed interstellar visitor. After Oumuamua, after Borisov, each one different, each one instructive, teaching us about other solar systems, other chemistry, other possibilities. But this one's the most extreme, most active, most puzzling, the test case for our understanding. Scientists worldwide are watching, calculating, debating, not because they expect aliens, but because they recognize significance. This object challenges our models, expands our experience, forces growth in understanding. The radio detection particularly intrigues SETI researchers, not because it's artificial, it probably isn't, but because it demonstrates capability. We can detect radio emissions from interstellar visitors, we can monitor these frequencies, analyze these signals, search for patterns that shouldn't exist. The technology works, the methodology is sound. Now we wait for the right signal, if it exists, if it ever passes through, if we're listening when it does. That's the broader context Loeb's work illuminates. We're developing tools to answer ancient questions. Are we alone? What else exists? How would we know? Each interstellar visitor provides practice. Each observation sharpens technique. Each anomaly teaches discrimination between natural strangeness and something more. The December 19 closest approach represents culmination. Months of observation reaching crescendo, our best opportunity to resolve mysteries or discover new ones. Telescopes worldwide are coordinating observations, radio arrays, optical systems, infrared detectors, radar installations, space-based instruments. Humanity's full astronomical capability focused on one object, one mystery, one question. What is 3I Atlas really? The data collected will feed analysis for years, models refined, theories tested, understanding advanced. Whether conclusions prove mundane or extraordinary, the process itself has value, generates knowledge, pushes boundaries. That's what Loeb's controversial analysis achieves. Not answers, not proof, not conclusion, but questions worth asking, mysteries worth investigating, possibilities worth considering. The scientific method applied to the edges of knowledge, where discoveries hide, where breakthroughs wait, where human understanding expands, the object continues its journey, accelerating strangely, venting massive quantities of exotic ice, broadcasting radio emissions at watch frequencies, following a path that started near another star. Each observation adds data, builds evidence, shapes interpretation, but the full picture remains incomplete. Pieces missing, connections unclear, conclusions provisional. That's where we stand today. Between knowledge and mystery, between natural and unknown, waiting for data to tip the balance. The coming weeks will be decisive. December observations with unprecedented precision, JWST's infrared eyes, Earth's coordinated telescopes, radar probes, spectroscopic analysis, trajectory refinement, each measurement moving us toward truth. Whatever that truth might be, natural comet with exotic properties, or something that expands our conception of possible, the data will decide, the evidence will determine. Science will follow where observations lead. That's Loeb's framework. That's the investigation structure. That's how we'll solve this mystery. Or discover it's bigger than we imagined. The radio signals continue. The acceleration persists. The mass loss remains extreme. The chemistry stays foreign. All documented, all measured, all real, waiting for explanation, demanding understanding, challenging our models of what nature creates, what physics allows, what might exist, beyond Earth, beyond our solar system, beyond current knowledge. That's the story still being written, the investigation still proceeding, the mystery still deepening. The 19th of December 2025 approaches rapidly. Closest encounter, best observations, potential resolution, or perhaps the beginning of larger mysteries. Time will tell. Data will determine. Science will reveal what 3I, Atlas, really is. Natural wonder, or something unprecedented. The universe keeps its secrets until we're ready, ready to observe, ready to measure, ready to understand. That moment approaches, the data accumulates, the mystery waits, and we watch.